Hello everyone, I'm back with a new video and I hope all of you are doing really great. And in this video, we are going to talk about something very interesting uh, about the aircraft engines in this episode. But before we get into the details of that, I would like to start this episode with a very good news or a very positive news. Uh, Probably all of you have been following that recently US and Iran had reached uh, kind of an agreement to stop their uh, war or attacking each other. They kind of decided to stop on that, and further discussions and negotiations are going on. But as this agreement kind of came into effect, so there is some immediate impact or immediate positive impact, I should say, that we could already see. So the major impact what we can see is that the oil tankers started to move towards Hormuz, and because of that, the oil which was at a point of time was at around 126, more than $126 per barrel. So it has started to come down, and recently, I think today it has come down further, and it's somewhere closer to around $70 per barrel, which is a really great news because that is the level it was pre-war or pre-conflict situation. So this shows that there is good enough confidence about this truce uh, holding up, and also there is good possibility of more Iranian oil coming back to the market, which was out of the market for quite some time. So because of this negotiations and this discussion, so there is a good possibility of additional uh, availability of oil in the market. So that will further ease the constraint, that will further ease the kind of price pressure which we were seeing over last quite few months. So that's a positive news, and with that, let's get into the more details of uh, the the uh, the main topic, about the engines. So the context of this discussion is that recently I was in a discussion with some of my friends from the industry, and we were discussing that why India is not able to develop its own jet engine so far, and why we are struggling. So while a lot of us are already aware from various news sources and all that, but what I thought that I would probably share a little more for my viewers to understand better that uh, the jet engines in general are a very complex piece of engineering. Okay, and when the jet engine is running, it's not just about a simple compression, combustion, and exhaust, but it takes a lot of additional uh, you know uh, uh, engineering considerations into the designing and development of the engines. And I will talk a little bit about those so that you can understand better about what they are and how uh, different considerations are being made. So let's first try to understand that you know uh, a lot of us have already kind of know that you know mm, the boilers, industrial boilers, so they are mm, you know they are operating, they're generally the operating temperatures are somewhere around 500 to 600 degrees Celsius, which is a, a huge uh, temperature that any of us can imagine, right? But and obviously as they uh, become more efficient, or the temperature at a, they they are being operated at a higher temperature for better efficiency, or uh, uh, generating more uh, power. uh, so for that, it goes around up to 650 or something like that. But that's a very high temperature. We obviously do a lot of coating for saving the materials from any kind of corrosion and erosions because of this temperatures changes and the stress, as well as any kind of melting of the base material. Now, uh, now think about the situation where the uh, the materials which are being used, or the operating temperatures that are being uh, used for some of the jet engines today, are more efficient, more capable engines to power some of the bigger uh, newer, bigger jets, as well as the faster fighter jets today. So they operate somewhere around 1200, 1300 degree Celsius, and in that kind of temperature, it's not easy for any normal material which we generally know of to sustain that kind of temperature, right? So now think about materials like you know uh, super alloys like inconel or something like that. So even they start to degrade their material characteristics beyond 700 degrees Celsius, and as the temperature further grows, so they further degrade their material characteristics, and that means when if you are using those materials at a uh, you know very very high temperature, they might actually melt. So same, take the alloys based on you know the materials like uh, other titanium based alloys or something like that. They starts to degrade at a even lesser temperature, like 450 to 600 degrees Celsius. They starts to kind of lose their material characteristics. So now, taking those things into consideration, how this jet engine being developed or being utilized, those metallurgical uh, uh, challenges being overcome and created those engineering marvels. So, and as you know, those materials also have heavier weight than simple aluminum or some of the other uh, alloys or stainless steels or materials like that. So what happens is that, so based on different kind of use, different kind of temperature, operating temperature for that particular zone in the aircraft, so different kind of materials are being used. While the say the titanium based uh, materials are being used for the compressor blades and the liners, uh, they are being also coated with some of the specific coating materials, and so that their efficiency and their degradation can be reduced, and their efficiency can be increased. uh, Similarly, the combustion chamber and the lining are being coated with some of the ceramic materials, some of the you know the yttrium stabilized uh, zirconia is one of the material that are being used widely. But also, apart from that, there are many newer chemicals or materials that are being used, especially on the rare earth uh, and the zirconia uh, that are being used. Also, the inconels and the tougher base materials are being used for the turbine blades. And also the turbine blades and the disc, those not just the materials, but also it requires kind of cooling holes or ventilation holes, so that the better uh, air uh, cooling air can be circulated or passed through. And on top of that, then there are uh, certain other materials that are being used, what we generally know as thermal barrier coating. So those materials are also being used for that. On top of those base material, then you use a bond coat, and then on top of that there are those materials. And those materials application is, again, it's not like your industrial use, or coating at your maybe for your vehicles. Sometimes we do this ceramic coatings and all that. So it's not like that. It's a much specialized process that goes through a lot of specialized systems, as well as quality control processes and all that. And any uh, even the even the smallest of uh, material defect can lead to catastrophic failure. So all these things, while you might ask that when we already have those knowledge, we have the capabilities, and in terms of getting those materials and access to those materials, then why we are not really able to do that? So definitely it's a complex engineering process, and it's not like readily available uh, to the uh, general, you know to all the countries, uh, like uh, you can just google it and start doing or start developing those materials and those designs, those airfoil designs and all that. Having said that, uh, we are really working very uh, uh, I would say at a very fast pace now, because from the government side, also from the central government uh, side also, there are a lot of push about moving faster on this aspect, and create the a smaller miniature version, at least which can help uh, some of the unmanned vehicles to be powered soon, and in future we'll definitely reach to a level where we'll be able to develop the engines of say 90 kilowatt newton kilowatt uh, 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 thrust, or maybe 120 uh, newton kilowatt newton thrust engines. So that is the, I would say, uh, the larger goal, and I'm sure that our teams in GTRE, and also in some of the private organizations, they're working closely on that, and we would be able to develop those very very soon. So with that, I stop this video here, and if you like this video, and you are liking our earlier videos, please like, share, comment, and let me know about other topics that you would like to hear about. Thank you.